Well, welcome to another Tyrrell Classic Workshop. We're looking at a fine piece of German engineering this time round. This car's coming for a tune-up, but it's worth a video because it was right up there in Mercedes-Benz hierarchy in the late 1960s. This is a 280 SE W111 3.5 litre. It's basically underneath the skin. This is what was called a Ponton Mercedes. Again, still a W111, but it was the Flockhesse, I think it was in German, if I'm not mistaken, the Fintail saloon, and it came out, I think, late 1950s, 1959, something like that. The Fintail, and it was a very, very successful model. It was the successor to the Ponton, as it was called, which referred to the pontoon-style chassis construction of Mercedes-Benz first really important model after the Second World War. The Fintail, it's had two interesting things. It was the first car to have crush zones, as they were called, which meant basically this area here and the area at the back were deliberately designed to crumple under impact, to absorb kinetic energy, to absorb an oncoming car or whatever. And then here was what's called the passenger safety cell, which was deliberately strengthened as opposed to deliberately designed to crumple area of the car. So it was a sort of this far and no further. And just about every car made these days has got crumple zones and a safety cell. So that was on the saloon. It got transferred over to this, which came later. This was in 1961, this coupe style, and it was designed it was a very different design to the Fintail. It was a much more rounded, dare I say, less US influenced, more modern design. The US was moving away from the Fintails and chrome and pointed tail lights and all sorts of weird and wonderful and fantastic things like the 59 Cadillac DeVille or Special 62, I think it was called. They went for a more conservative design, and Paul Brack, who has designed the most amazing selection of cars, designed this based on the Fintail, and it took it up market quite considerably, with a price tag to match. But this is an interesting piece of automotive history because it's one of the first cars to successfully use electronic fuel injection, which again, virtually every car these days has got. So this was really pioneering at the time. The first, just to go back to the 1950s, car manufacturers realized that a carburettor was a fairly primitive device. It relied on engine vacuum to suck in fuel through various orifices at various times. There was no room for on-the-road feedback or adjustment or anything, a lambda loop, as it was called. That was brought in the 1980s. There was none of that. Carburettor, very basic instrument, worked very well. But the Americans in particular started to look at fuel injection as an alternative. Electronic fuel injection. And this was a company called Bendix, which are known for all sorts of things, washing machines. They designed a particular type of starter motor, such as were used on BMC A series, the sort of Bendix pinion, if you like, where the starter motor turns and it actually throws the pinion, because it's on a spiral, it throws the pinion into contact with the flywheel to start the car. Some people say that's not the right name for it, but I'm just illustrating what the different things they did. Another thing they did was invent a braking system called Treadlevac, which was a servo-assisted braking system. When brakes on cars started to become bigger, because cars were getting bigger, they needed to have an assistance for the brake pedal so that you didn't have to sort of, just to pull up at a junction, never mind an emergency stop. So Bendix came up with the Treadlevac system, which was a very complicated system that was actually built into the frame of the car. So it was not easily removable or modifiable. And one of the cars that had that system on was the Mercedes-Benz 300 SL Gullwing. Up until, I think, if my memory serves me correctly, chassis 353 in 1955 had the Bendix Treadlevac, as it was called, braking system. And after that, they went on to a more conventional, as technology allowed, ATE brake servo. But so Bendix were into all sorts of things, and they came up with an electronic fuel injection system. I'm going to explain how it works a little more. They launched it on a couple of cars round about 1957, 58, a Chrysler and something else. And ultimately, it was a dismal failure, unfortunately. So much so that they actually recalled the cars that had the electronic injection fitted because it kept breaking down and not working properly. And they recalled them and retrofitted them with carburetors for customers to save face, essentially, and reputation. And then what happened was Bendix decided and Chrysler and AMC, actually, American Motors, that was the other manufacturer, they decided to call it a day, and Bosch in Germany bought the rights to the, it was called the Electrojet injection. This Bendix system, they bought the rights to that, and they turned it into what they called the Jetronic system. It later became known as the Jetronic system, Druck for pressure in Germany, because it measures the pressure of the air going into the engine or the vacuum. Later were the K-Jetronic for constant, and then L-Jetronic for Luft. These came later on. But we're talking about the early electronic fuel injection systems here. Bosch developed this, and it was an expensive system to produce, the Jetronic system. It relied on some military specification hardware in the various components on it. In fact, now seems like as good a time as any. This is actually, here's one that we made earlier. This is the electronic control unit from this car. This car's got an identical unit. It's also suitably bulky. This is full of old world electronics, transistors, diodes, resistors, capacitors, all sorts of things. It's got a huge plug which a great big electrical connector fits on there, a multi-plug. Bosch developed it, as only the Germans can, to the point where it became very reliable, infallible almost. It wasn't Mercedes who brought the first Jetronic Bosch system out. It was Volkswagen on their, what they called the Type 3, which was a fastback from the late 60s. It was a sort of bigger and more normal Beetle, if you will. It was a family car as opposed to a runaround. Mechanically very similar, but because of the tightening emission laws in the US, and this is where it comes back to the carburetor, because of the tightening emission laws, particularly in California around smog and things like that, the poor old carburetor and mechanical fuel injection systems weren't up to the job. They weren't able to meter the amount of fuel going into the engine accurately enough. So what they did was they actually built in a little bit of extra richness in the mixture, so they made a slightly larger quantity of fuel over air going into the engine in order to mask any problems that it might have had, because if it went weak it would cause misfires, less fuel for the amount of air going in. They didn't want that, so carburetors and mechanical fuel injection systems really like working properly when they're slightly rich. That means they can't pass emissions laws because there's some unburnt fuel in the mixture because it's rich. So, bit of a conundrum. The answer, as we now know, was electronic fuel injection. And the humble VW Type 3 was the first ever car to have a reliable electronic fuel injection system on it. Bosch really pushed the boat out with this. They spent a fortune modifying and developing the Bendix system. They bought the patents, and this car, so we come full circle to this car has got a 3.5 litre V8 engine, which was the staple of high-end Mercedes for a number of years, not the 600 with its 6.3 litre engine or the 300 SEL 6.3. This was the next engine down, apart from the 4.5 litre engine, which was based on this, which was, I think, destined for California only for some reason. This engine, the 3.5, and it's got plenty of poke, this engine. This is a fast car. Considering its fairly uncompromising aerodynamic bluffness, This car will do thick end of 130 miles an hour, which is serious for a 1960s sports saloon. This is a very, very comfortable car. This, as I say, this was fearfully expensive when Mercedes brought this to market. They made a cabriolet version of this, and I actually had a right-hand drive one in years ago. They made 68 280 SE 3.5 cabriolets, right-hand drive, and I had one in, and they are now fetching round about £250,000. They're quite a valuable car. Because they're great to drive, actually. That 3.5 litre V8 produces 200 brake horsepower, which is plenty to pull this along, as we'll see in a little while. And it really is, this was something of an ultimate for Mercedes in the 60s, excluding the 600, which was way off the end of the scale in everything, cost, everything. But this was still a serious car. So this is actually the first production V8 engine to have reliable electronic fuel injection. So it's quite a special car, actually. It's come in for a tune-up. I'm going to just explain how the Jetronic, or later pressure-orientated, pressure-regulated Jetronic injection system worked. So let's take a look at the business end. Well, I do want to say, first of all, I normally reserve this for the end of the videos, but we have a wonderful subscriber number, and thank you to everybody who does subscribe and support the channel. I would just say it helps the YouTube algorithm. If you do want to subscribe, please do so. It does help. Press that subscribe button. It makes a big difference. And thank you to the 192,000 odd people as we make this who have supported us. Right, let's dive into this. This is the air filter, air intake there, and I'm going to just remove this, and this is the air temperature sensor, which is part of the injection system. It measures the temperature only, not the mass of the air. So if you're doing mountain climbing up to high altitudes, this will not compensate for that as a modern fuel injection system does, but we'll have a look at what's going on. So I'll just quickly take this off. So this is the business end of this V8 engine. It's an overhead cam engine, which is very unusual for the US market. Most cars in the US were, the vast majority were pushrod engines with a cam in the middle. Mercedes went for overhead cams just to help breathing, and that's the way they did it. Simple as that. It was their choice. Here we have the throttle in the middle, which is quite large. Actually, there's a serious amount of air can go through that. In fact, the 450 versions in the 4.5 litre that was sold in Europe and the UK in the 450 SL, the 107 engine, Mercedes, is an absolute flying machine, actually. I remember that I've tuned a few of them over the years and worked on them, and they were seriously quick. This is quick enough, but so basically these are the 8 fuel injectors here, 4 per side, and they are what's called port injection. So they squirt a mist. It should be a mist round a circular pintle at the end of the injector, which mists into the inlet port and then gets pulled in by the piston on the inlet stroke, and that's how you get your air-fuel mixture. So there are various sensors in here which feed information to the ECU. We've got the coolant temperature sensor, the air temperature sensor I mentioned before. We've got this temperature sensor here, which measures throttle position and how quickly the throttle is being snapped open for sharp acceleration. This little baby over here is what's called the MAP sensor, manifold air pressure sensor. So that measures the vacuum that's going on. When the engine's at idle, the butterfly is closed, the engine is throttled down to an idle speed. As you open the engine on a petrol engine, obviously it opens up and lets more air into the engine. So a petrol engine is always creating a vacuum and pulling air in. to a greater or lesser degree. The whole purpose of all this information going back to the electronic control unit is to determine the amount of fuel going into the engine relative to the amount of air. That's what it's all about. And this is where Bosch really did do very well with this, because it was, by the standards of the time, very accurate at metering the fuel. So this is the fuel rail, as it's called. It's a circular system. It feeds back. This is the pressure regulator, which holds the pressure constantly in this at 30 psi or 2 bar. And then it has a pressure relief there that goes back to the tank. If you have an excess, the pump is always delivering more than 30 psi, so you have to have a regulator to regulate it down. So these injectors are always under pressure with fuel from the top, and they have a little electrical connector on each of them. And what happens is the ECU processes all the information that's being sent to it, and then it's all about the duration of the injector. So to make life easier for themselves, Bosch divided this into 4 subdivisions. So at any one time, there are 2 injectors injecting fuel. It is not fully sequential, which means every injector is injecting in at the psychological moment when the piston is on the downstroke, and you get maximum atomization of the fuel because it's being drawn in at precisely the right time under great vacuum. It causes the fuel mixture to atomize very, very well. But this was state of the art at the time. So in fact, Jaguar when they used this system on the V12s, it was 3 injectors per cycle. So at any one time, 3 injectors would be powered to distribute fuel to as best they could get it just before the cylinders were about to pull it down and combust it. So it's a very clever system. This fuel is constantly held under pressure, and these are electromagnetic valves, these injectors. They just go and open for a fraction of a second to deliver precisely, or pretty close to precisely, the amount of fuel that cylinder wants. And this is all controlled by that big ECU, a series of transistors determining the duration of how long these injectors should be. And when they're set up properly, these really are, as I say, they're a rapid car actually for the day, considering they're a big sports saloon. They're not necessarily a blood and thunder sports car. So I'll just start it up. I've finished doing this. We've got an idle mixture screw on the electronic control unit, a big thumb wheel that you can turn to regulate the mixture, fine tune it. This car is not in Concours condition. It's enjoyed by its owner as it is, and it's very original. It's hardly ever had any structural welding, he tells me, on this car, which is remarkable for a 1960s car. So it's very original. He's not afraid to use it because of the fact that it's not spick and span and shiny. But what I'm going to do is start it now. One other thing to mention as we're getting into the nerdiness, the later versions of this used what's called a cold start injector. And when you turn the key to start the engine, hot or cold, there was a unit on the engine which measured the temperature, and the cold start injector was basically another one of these, and if it was cold, it would give a shot of fuel, neat fuel, into the inlet just to help it catch as the injectors came to life. And on a Mercedes 600, for example, the engine can fire instantly. As soon as you turn the key, the first compression, boom, it's off. That can be a good thing and a bad thing, because it hasn't actually just had those few moments to build up oil pressure before the engine starts. I'm thinking of the Mark I and Mark II Golf GTIs in the 70s and 80s. You turn the key on those and literally, it's off. And again, it hasn't had time just to build that oil pressure up. Nowadays, if you start an internal combustion engine car, it's normally automatic on the key or the starter button. It will wait for a second or two. It will crank for a moment, hot or cold, under any conditions, until it fires. And that's a deliberate strategy by the manufacturer to make it last longer so that the oil can get round. So I'm going to start this now. You'll notice it's just there's the beat of the cylinders as they compress, and then it bursts into life, which is actually far preferable to it firing absolutely instantly. Let's do it. So it doesn't take much, but it wasn't immediate. It was just a second or two before it caught. And this is very steady. I'm not going to do the balancing coin test because this is 1960s technology, and it wasn't designed to idle as smoothly as the likes of a Rolls-Royce V8. It was more about efficiency. So it is mechanically a noisier engine, this, than a Rolls-Royce V8 of the same period, or a Jaguar V12 or something like that. But it's very, very responsive. Not a lot wrong with that. When it came in, it was firing on 6 cylinders. It was ready for a birthday. We've got it sorted out, but it's rippy like a motorbike engine. This is the 1960s. How about that? So it's high time we took this car for a run on the road. Well, here we are. One thing I forgot to mention, because every single Tyrrell's Classic Workshop video has been unscripted and improvised. I've done some prep work, but most of it is just nearly all of it is just anecdotal from my years in the motor trade. And one thing I forgot to mention was that seatbelts, inertia reel seatbelts, were actually pioneered on the Mercedes W111 as well. So that's why I am wearing my inertia reel seatbelt. Amazing that Mercedes were so ahead of the curve, really, with things that have been accepted into every. Again, is there a car made on the planet with non-inertia reel seatbelts? I suspect not. It's idling beautifully, this car. It's behaving exactly as it should, and it is super responsive. It's so funny. Rolls-Royce throttle linkages were the same at the time. Porsche 944, when it came out in the 1983, was it? Something like that, 1984. It actually had a logarithmic throttle action. So in other words, it had a little cam right on top of the engine, and it was designed that the first 30% of foot travel represented the first 20% of throttle travel, so that you didn't put your foot down and get launched forward by the throttle suddenly snapping open. Although if you wanted to, you could just floor it. But a lot of car manufacturers over the years have actually tamed down throttle response. On modern cars, modern internal combustion engine cars, if you select sport mode, it actually alters the throttle response on the engine and makes it more eager. But the point I'm making is, this car and the likes of the Rolls-Royce Silver Shadow, when it all those years it was in production, had very sharp throttle responses, what I would describe as linear throttle responses. So you push your foot down a quarter of the way on the accelerator, and you open the butterfly on the throttle a quarter of the way. And actually that makes for quite a big difference when you're driving it. It means that the car launches itself off the line. And I've seen people driving Rolls-Royce Silver Shadows who aren't used to them and taking off like a scolded cat because the throttle linkage was so trigger happy. It really was. And this is the same. You only have to touch it. As I showed earlier, when the engine is tuned and on song properly, you only have to touch them and they're off. They really are. Yeah, I mean, just a delightful car, this. It really is. The kickdown is working beautifully. The Mercedes automatic transmissions of this era were never the smoothest. The Americans always had the advantage with the turbo hydromatic or the torque flight or the transmissions that were coming out around that time. Mercedes-Benz were rugged and purposeful, but not as smooth as the American auto transmissions. Okay, we're just going to pass this cyclist now, and then we'll open the taps on this little beauty and see what all the fuss is about with that 3.5 litre engine. Here we go. There we go. We are gaining momentum. That just went from 4th to 3rd there. So it wasn't quite as electrifying as I was expecting. So we'll turn round at our chosen spot and just try that again. There we go. Yeah. Not too shabby, that. This is a 1969 luxury car, and it does pick up. Here we go. Lovely. Quite the flying machine. You could give some people a serious surprise driving this car at that time. Even today, people don't expect a classic car to perform like this. Just making sure I'm in the right gear. Yeah, it's a fun place to be, this. And it also has an electric sliding sunroof. There we go. Just the thing for the ejector seat. Absolutely beautiful. The suspension is a bit firm, but there is negligible body roll at the sort of sensible speeds I'm doing. It feels expensive. It feels hewn from the solid. Even after all these years, it feels really substantial, this car, and so stylish. It really does. I've noticed when I've been driving this car, people do look at it with very admiring glances. There's no malice or anything like that, unpleasantness. They genuinely just like it because it's a classic car. Well, that concludes another Tyrrell's Classic Workshop video. Hope you've enjoyed it. If you've enjoyed it half as much as I have, I've enjoyed it twice as much as you. See you next time.